Hello, and welcome to the first in a series of videos where I'm going to explain how to do various tasks and calculations that we use on a daily basis when we're at sea. In this short video, I'll be showing you how to calculate the time of sunrise for a given position using the Nautical Almanac. I'm going to be using NP314, which is the Nautical Almanac published by the British Admiralty and is the one most commonly found on board merchant ships. If we turn to the daily pages, which start on page 10, we find that the Nautical Almanac has the times of sunrise, sunset, moonrise, moonset and twilights listed on the right-hand page for every set of 3 days. The times printed within these pages of the almanac refer to the time of the event occurring at the prime meridian, reference to Universal Time Coordinated, or UTC, for the dates that are stated at the top of the page. The time of the event also changes based on latitude, which is why the almanac lists the time of the event for a number of different latitudes. In this video, I'm going to show 2 examples, starting first of all with calculating the time of sunrise if we were located on the prime meridian. The Royal Observatory at Greenwich in London is located on the prime meridian. The position of the observatory is 51 degrees, 28.6 north, and 000 degrees, 0.0 minutes west. And we want to calculate the time of sunrise on the 10th of April 2016. Unfortunately, the latitude of the observatory is not listed in the almanac, so we will have to interpolate between the 2 closest latitudes. In this case, 52 degrees north, where sunrise is at 0514, and 50 degrees north, where sunrise is 0517. By interpolating between the 2, we find that at 51 degrees and 28.6 minutes north, the sunrise will occur at 0515 Universal Time. Now we can leave it as this, as we're probably working in Universal Time anyway. However, if we want it in local time, we have to take the time zone into consideration. In most cases, we would be converting UTC to the ship's time, and as we should know what our time is relative to Universal Time, we simply add or subtract the difference to get the ship's local time. In the case of the Royal Observatory, we know that on the 10th of April 2016, the UK is on British Summer Time, or 1 hour ahead of Universal Time. Therefore we simply add 1 hour onto our sunrise time to get the local time of sunrise, which would be 0615 British Summer Time. In the previous example, our position was on the prime meridian, so we only had to adjust for the latitude and the time zone. So how do we calculate to the different longitudes? Let's calculate the time of sunrise on the 10th of April 2016 at a position 45 degrees north and 090 degrees 15.5 minutes west. You'll notice hopefully that 45 degrees north is one of the latitudes we have a sunrise time for in the almanac. If it wasn't, then we would simply interpolate just as we did in the previous example. So from the almanac, we see that the time of sunrise at the prime meridian on the 10th of April at a latitude of 45 degrees north is 0524 UTC. As our position is west of the prime meridian, the sun will rise later, but how much later? There are different ways of calculating the time difference, but the quickest is to simply convert our longitude into time, commonly referred to as longitude in time, or abbreviated to LIT. This is a really simple calculation, especially if you're using a scientific calculator. We simply divide the longitude by 15. So in this case, we're dividing 90 degrees, 15 minutes and 30 seconds by 15, which gives us 6 hours, 1 minute and 2 seconds. Or 6 hours 1.03 minutes, which we're going to round off to 6 hours and 1 minute. As mentioned earlier, we're west of the prime meridian, so we simply add the 6 hours and 1 minute to the time we took from the almanac. This gives us a sunrise at our position of 11:25 Universal Time. Now if we were on a ship, we'd know the time difference between our ship's time and Universal Time, or we could just leave it as UTC. However, in this example, the position happens to be near a town called Holton in Wisconsin, USA, which is observing the United States Central Time Zone with daylight savings. This means it's 5 hours behind Universal Time. Therefore, the local time of sunrise at our position would be 6:25 in the morning. I hope this video was useful to you all. If you liked it, please click the like button and join me next week when I will be explaining how to calculate the compass error using a sighting of the sun. To make sure you get notified whenever I post a new video, don't forget to click the subscribe button.